talk about the introduction of our topic. What is differentiation? Differentiation is a process of finding a function that outputs the rate of change of one variable with respect to another variable. We need differentiation when the rate of change is not constant. Other than that, why we use differentiation? Differentiation can help us solve many types of real-world problems. We use derivative to determine the maximum and minimum values of particular function such as cost, strength, amount of material used in a building, profit, loss, and egg. It also used to solve the related rates problems involve finding a rate at which a quantity changes by relating that quantity to other quantities whose rates of change are known. The rate of change is usually with respect to time. What are the other applications of differentiation? We have rate of change of quantity, increasing and decreasing function, tangent and normal to a curve, maximum and minimum values, Newton's method, and linear approximations. But under this video, we will focus more on apply maximum and minimum values. What is maximum and minimum values? Maxima and minima are critical points on graphs and can be found by the first derivative and the second derivative. The critical point of a function is a value for which the first derivative of the function is 0 or undefined. A critical point often indicates a maximum and a minimum or the endpoint of an interval. If the second derivative at a critical point is positive, then it is a minimum, and if it is negative, then it is a maximum. In mathematics, the maximum and minimum of a function, known collectively as the extrema, are the largest and smallest value that the function takes at a point either within a given neighborhood or on the function domain in its entirety.
Question 1. A manufacturer of chocolates is launching a new product in novelty shape cardboard boxes. The box is cuboid with cuboid shaped tunnel through it. The head of the box is HCM. The top of the box is a square of side 3xcm. The end of the tunnel is a square of side xcm. The volume of the box is 2000 cm cube. A. Show that the total surface area ACM square of the box is given by A equal to 16x square plus 4000 over x. B. To minimize the cost of production, the surface area A of the box should be as small as possible. Find the minimum value of surface area A. For question A, we need to use the volume given, which is 2000 cm cube. Using the information above, we find the H value, which is 250 over x square, which is the first equation. Next, using the information above, we need to find the surface area, the equation of surface area, which is 16x square plus 16xh, which is the second equation. Next, we need to use the two equations that we get, which is h equal to 250 over x square and 16x square plus 16xh. With the value of h that we get, we need to substitute the value into the h from the equation 2. And we get the answer 16x square plus 4000 over xcm square, shown exactly as the question. For question B is, we need to find the minimum surface area. First, we need to do step 1, which is to find the derivative. Using the surface area equation given, we need to find the derivative of A, and the answer is 32x minus 4000 over x square. Next, proceed to step 2, let the derivative equal to the 0. Let dA over x is equal to 0. 32x minus 4000 over x squared equal to 0. And from the calculation, we get the value of x, which is 5 cm. After that, we proceed to step 3, is to do a second derivative test. To do a second derivative test, we need to find the second derivative first. From the calculation, the second derivative value that we get is 32 plus 8000 over x cubed. After that, using the x value that we get, substitute the value of x into the second derivative that we get. And the answer that we get is 96, which is higher than 0. So, from the second derivative test, we get that x equal to 5 cm is a minimum value. From the step 3, we know that the x value is a minimum value. So, we use the x value to find the minimum surface area. Substitute the value of x into the surface area equation, and the final answer is 12,000 cm square.
The question is, the frame as shown in the diagram is formed by using a piece of wire of length 120 cm. For the question A, express y in terms of x. For the question B, show that the area ACM square is given by A equals to 26x in parentheses 10 minus x. For the question C, determine the maximum area of the frame. question A, we use a parameter formula which is 2 multiply 5x plus 2y plus 6x equals to 120. After that, we will get 2y plus 16x equals to 120. And then 16x, we move to right hand side, which made 2y equals to 120 minus 16x. And all of the equation, we will divide with 2 and we'll get the answer y equals to 60 minus 8x as the final answer of this question. For question B, we will make a frame into two sections, which is triangle and rectangle. Firstly, we will search the head of triangle with use Pythagorean theorem formula, and the base of triangle, which is 6x, we will divide 2 and equals to 3x. The equation of head triangles is square root of 5x square minus 3x square, and the head we will get 4x. After that, we will search area of frame, which is the total area rectangle plus area of triangle, which is y multiply 6x, but we will use y in term of x, so 60 minus 8x and multiply with 6x, and plus 1 per 2 multiply 4x multiply 6x, and the answer we will get 360x minus 26x square. But that's not a final answer, that's question 1. So we have to factor the equation and we will get 36x in parentheses 10 minus x, so that we will get the answer shown in the given questions. And for the last question, which is C, we have 4 steps, and we will use equation A equals to 360x minus 36x squared, because that is the easy equation to derivative. Okay, for the step 1, we have to find the derivative, which is 360 multiply 1 and power x minus 1, and then minus 36 multiply 2 and also power of x minus 1. So we will get answer 360 minus 72x. Step 2, we have to let the derivative equals to 0. So 360 minus 72x equals to 0, and we search the value of x as usually, and we will get 5 as a value of x at the final answer for this step. Step 3, we have to make a second derivative test, which is 360 multiply with 0 and minus 72 multiply 1 and power x minus 1, and we will get minus 72 as the answer, which is minus 72 less than 0. So we can conclude that x equals to 5 is maximum value. And the last step is we enter the value of x, which is 5, into the error equation that given in the question B, and we will get 900 cm square as the answer for this question.
Basically, we can conclude that there is a connection between applied maximum and minimum problem with differential. Application of differentiation is an important concept for solving maximum and minimum problem. The step used to solve the given question is to find the derivative. Then, let the derivative equal to 0 and find the value of the variables. Next, find the second derivative, and if the second derivative more than 0, it is minimum value. Meanwhile, if the second derivative less than 0, it is maximum value. Lastly, a minimum has been found by substituted y value into surface area equation. In conclusion, by using application of differentiation, it can help us to solve various types of problems that occur in our daily life. We can conclude that the first derivative test or the second derivative test can be used to resolve optimization problems. However, before we can use the technique, we must first understand and analyze the question in order to construct a function. As a conclusion, we may apply the first derivative approach to determine the manufacturer's maximum profit. The application of a maximum or minimum problem is known as optimization, and it is commonly used in our daily life. This discovery benefit people in understanding and calculating business profit and loss, as well as goes to guarantee they do not lose money. It is a very beneficial and practical way for dealing with business or other challenges in everyday life. So, learning to solve applied maximum and minimum is not in vain because we know how this application may help us in the future. Thank you.